And I've been asked to introduce to all of you Dr. Richmond. He's from Santa Cruz and he works for USGS. But before, I just want to tell you a little bit about how I know him. Last summer he came to my office and he wanted to do some coring down in Aliomanu. And so our office allowed him to go down and do some coring, and he called us earlier this year to come back and do more coring so that he could look for some tsunami deposits. So without any more interruption, this is Dr. Bruce Richmond. Thank you very much.
Aloha, and you can just stand anywhere. Stay back here? All right. Aloha and good evening. Thank you all for coming out. I'll introduce my group in a minute, but we're usually at scientific conferences talking to other scientists and stuff, and we really appreciate that you provided this opportunity to discuss with the public the kinds of things we do, because we are either academics or government workers, we're public servants. And this is one of the best ways we can get that information out is in local groups. So it's informal, you can ask questions. I'll probably give maybe a half an hour presentation or so, and then we'll be around for any questions afterwards. But this isn't all my work, it's a lot of it due to my colleagues. There's 5 of us here from the Santa Cruz office of the U.S. Geological Survey. That's part of the Department of Interior. There's Bruce Jaffe, is he? Okay. Bruce Jaffe, he's well known internationally. He's our project chief for a tsunami project at the USGS in Santa Cruz. Who else is up on the list? Oh, Guy Gelfenbaum is in here. Sean Paul LaSalle is from the University of Washington. He's a modeler, sedimentologist, do-it-everything guy. He did a lot of the planning to get us out here, and he's just a great person to be around. James Bishop is a University of Hawaii Manoa graduate, just recently graduated. He's a hydrologist, and he's been providing a lot of expertise for us. This is his second trip out here with us to Hawaii. He's also worked in New Jersey with us. The final Santa Cruz person is Frances Griswold. She came to us from Central Washington University. She's got a master's degree and has worked on tsunami deposits in the past. And she's also one of the Jill of all trades with the project. Visiting or working with us from Australia is Catherine Shage-Goff. She's a geochemist and on the cutting edge of finding ways to geochemically identify tsunami deposits. And we're real happy to have collaboration with Catherine. Next up, Daisuke Sugawara from Tohoku University in Japan. He's a modeler, a sedimentologist, another person who's heavily involved in tsunami deposits and their modeling. And from the University of Hawaii. Oh, did I miss Piero? I did. No. He's from Munster, University of Hawaii. Current PhD student is Haonani Kane, and she's worked with us. She was with us last May, working here in Anahola and around the island. And we're happy to have her. She's searching for PhD topics and may use some of our cores for that. And last on the list is a visiting scientist from the University of Münster in Germany, Piero Bellanova. He's been a real help all the way along the way and keeps us in high spirits at all times. Plus, he's learning to open coconuts by himself, so he's doing really good at that one. So, because we are, what?
then I get butterflies, and then it, and I get dozens of butterflies in the flowers.
So was that a question? I didn't.
That was
No.
that was
Okay. 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 Our overall goal, the work we do, we hope that it will lead to improved public safety and community resiliency, and that's to survive or to not let natural disasters tear down communities. We want to be able to, I got it, I hope. Now, I can get back to the slides then. There we go. And we want to use that scientific research, and we're doing that to try and better understand and forecast coastal hazards. Right now, we're particularly focused on tsunami hazards, but a number of us have worked on coastal erosion, storms, and other processes. One of the things with tsunamis is they're relatively rare, although the last decade hasn't been quite like that. But because they're rare events, it's to understand how big and how often they may occur, you need a long record. And the written record, by far the longest, is in Japan, which goes back, it's a little hard to see, it goes back to 700 AD or so. So that's the most complete record in the world. You can see Hawaii is a really short record. Now, what these lines represent are individual tsunamis where there's a written record of that. And the color sort of relates to how big and strong they were. But the point of this is there's very little historical information on tsunamis, which makes it harder to predict how big of tsunami you might expect to get. And this group itself, we've spent since, at least our group, since 1998, we've been working on modern tsunamis around the world. Papua New Guinea, we've spent a lot of time more recently in Samoa in 2009, Chile 2010, and Japan in 2011. And the idea behind that is to better use modern deposits to help us interpret the past tsunami thing. So we collect a lot of different kinds of data when we're out there mapping modern events. And we use that to identify the historical record. But turning to Hawaii, there's three kinds of tsunami threats to the Hawaiian Islands. Locally generated tsunamis. This is where an earthquake or landslide will create a local tsunami. 1975, there was one in Hawaii volcanoes. I'll show some examples of that. It affects a relatively small area of coast. I'll talk mostly about distant source tsunamis and why they're so important here, but it's essentially tsunamis that are generated somewhere else in the Pacific and make their way ashore to Hawaii. And I'll talk a little bit about the mega tsunami catastrophic ones that are extremely rare. But Hawaii is one of the few places where we have evidence for really extreme catastrophic tsunamis in the past. What drives a lot of the tsunami generation are earthquakes and large earthquakes. This is a map, it's just world seismicity. You probably have heard in the past about the Ring of Fire around the Pacific. And this is where an area of volcanoes and very large earthquakes. And the Hawaiian Islands are sort of a bullseye with all these areas surrounding the seismic areas surrounding those. And the important component of that are subduction zones. These are where earth plates are colliding, and one slides under the other. They create very large earthquakes when they when the earthquake happens, the sea floor is displaced, and that's what generates the large tsunamis. And the more recent large ones are magnitude 9 and above kinds of events. Chile, Japan, these are the ones that have caused major destruction. I do want to talk a little bit about, it was December in 2004 when there was the Indian Ocean or the Indonesian tsunami. I think that was the first one I can recall seeing live on TV. You know, the news, you could actually see all the destruction happening. And it really brought home that these are really powerful events. And throughout the Indian Ocean, there was a total of over 230,000 people have lost their lives. And the epicenter, actually, let me back up one, if I can. This is Indonesia, the island of Sumatra. This is the center of the main, the epicenter for that large earthquake. You can also see they have a history of large earthquakes in the region. So they were somewhat, at least aware they could get extremely large events. I'm going to talk a little bit about Thailand, where it's not seismically active, and they have a much less awareness of the tsunami potential. But even Thailand itself had over 8,000 people perished in that. Sri Lanka, India, all of these are far from the actual epicenter of the earthquake. And a lot of these deaths could have been prevented had they been more aware and had plans in place. This is a map that shows travel times, all right, through the Indian Ocean, with the epicenters along here, with this being 5 hours. So Sri Lanka had 2 hours warning before they were hit by the tsunami, yet they still lost, I have to look back what it was, 20,000 people or something like that. So it was a lot of people. Thailand actually didn't have much warning. They had less than an hour before things. Folks right next to the epicenter had 15 or 20 minutes warning before that happening. The Maldives lost several hundred people, and they had up to 5 hours warning, but they didn't have a warning system in place. So in Thailand, they haven't had a tsunami in over 200 years, and so there was no preparation for it at all, no warning system. People were still out in the beach, in the hotels when the event happened. In 2015, we were there visiting. They've now built evacuation structures near the beach. They do have warning systems. They still have rebuilt the hotels on the beach, but now they have sirens and at least have warning systems in place to protect. Or
Where is that Viking picture from? Is that on shore? Is that on the right?
sorry, this one?
No, on the top right.
Yeah, this is yeah. Okay, this is looking from one of the hotels as the wave was coming on shore. I didn't want to show a lot of the destruction. You know, when we work after these events, there's a humanitarian crisis right away. And being geologists, you know, we want to get there as soon as we can and look at the forensic evidence of the tsunamis, but we also want to be mindful of what's going on. So we often wait, you know. We figure if the deposits, you know, we're looking for stuff hundreds and hundreds of years old, it can wait a few months before, you know, getting there after some of these events. But not long after that, there was a paper that came out, a science paper, that some geologists found evidence that actually would have told them that they have experienced major tsunamis in the past. And that if they had looked at that record and understood it, they would have been much better prepared for what happened. And we had a number of us here. Catherine, Daisuke, you were, Bruce, we're all there. This is for an International Field Symposium in Thailand to commemorate the 10th anniversary of the ocean. And they took us to this site where this is the 2004 tsunami deposit. And then material that accumulates slowly over time in a natural environment. And then here's this big sand from around 300 AD. And you couldn't dig a hole any place along the coast and not see stuff like that. So somehow that had been missed. And it's a real tragedy that that's happened. And that's what we're trying to do now, is extend the record back. Hawaii only has 150-year written record. And these events may be every 400 years or 1,000 years. So we want to try and identify those. So where do the earthquakes in the U.S. most frequently occur? Any ideas, or?
Fracking zone.
Yeah. Actually, it's Alaska. But that's not entirely true. The single most, the Big Island has hundreds of earthquakes every day. They're just really small. It's actually the most active in terms of daily number of earthquakes, but not the big ones. Alaska gets some big ones, and that's what, there's an event, there was a 1946 Aleutian tsunami. I think pretty much everyone in Hawaii knows about that. It was an 8.1 magnitude earthquake, which is, 100 times or 1,000 times less energy than a 9.1. 100.
Oh, wait, 10.
Okay.
It's 30 times less energy, 10 times less ground motion.
Okay. But it also created a landslide close to the center. Water level got 42 meters. All right, so what's that, over 100 feet? With 5 hours later, it struck the Hawaiian Islands. Over 150 people died. Everyone probably knows, the Lapohoi tragedy in the school there. It also impacted not far from our, a half an hour away from our home in Santa Cruz. We've been working on 1946 deposits in Pillar Point. And it affected French Polynesia and Chile. But one of the things that came out of that, the Alaska Aleutian subduction zone is potentially the largest threat to California and Hawaii coast. This is another travel time map for that. Here's the epicenter, so a little less than 5 hours to reach the Hawaiian Islands. And one of the things that triggered was the development of the Pacific Tsunami Warning Center, because no one had any idea that tsunami was on its way. So they established that warning center after the 1946 event. And they've also started putting together these travel time maps. So when there's an earthquake, the U.S. Geological Survey has seismometers. They can pinpoint where it is, how large it is, and then they can start figuring out. They send out messages and alerts. And I'll show some of that later. This is from a hazard atlas that USGS and University of Hawaii put together. And I'm highlighting, these are a little small to see, but I'm highlighting the wave heights, the run-up at the coast from that 1946 tsunami around Kauai. And you can see they're quite variable. 17 feet in Anahola isn't the highest, but it's certainly, when you see how low the valley is and stuff, it's quite dramatic. And of course, the highest up here in the Hyena area, we have some narrow valleys reaching the coast.
Is that from Alaska?
Great, yes.
A few years back, there was archaeologist David Burney working at the Makawahi Cave near Poipu Beach. He was an archaeologist looking for extinct birds, but they were doing pits within the cave. This is how this looked last May. And during that, they found evidence of a tsunami that overtopped the cave entrance, the sinkhole entrance, and filled it up with sediment along the floor. Well, that was 7 to 8 meters above sea level. This is where the cave site is. We wanted to take a look at that deposit, so on this trip, actually last Monday, they pumped out where the groundwater filled in and allowed us to get inside and actually look at the deposits and try and understand what happened in that in that event. And David Burney was working with Rhett Butler, who's a geophysicist at the University of Hawaii, and they did some models to try and figure out what size event would get within that cave. So they created computer simulations of a number of different tsunamis, and they found this East Aleutian one was able to create a tsunami that would get into that cave, and they modeled around the islands. And this is the comparison. The red is what the run-up they observed from the 1946 April Fool's Day event, and the blue is what their modeled larger event in the Aleutians would cause. And you can see it's quite dramatic, a 35-meter potential wave. And on the island of Oahu, they've actually modified their tsunami inundation or hazard zones based on the modeling. But that's all based on the Makawahi Cave site. So one of our purposes out here is to try and find other evidence for that. So, and the other is just some of the things why, people always ask why is it so high here and lower there? And there's a lot of complicating factors. In just what the coastal topography like, what's the offshore bathymetry, and how that affects the waves, the shape of the coast, the orientation of the coast, all these things. And then when it gets closer, bottom roughness and the coral reefs will affect the coastal vegetation. And then the size and period of a tsunami. If it doesn't overtop a beach, it'll just reflect off. So there's a number of complicating factors. But I think overall the science of tsunami science is really getting a lot better at recognizing all of that. So in May of this year, many of this group were involved in a reconnaissance survey on Kauai, Oahu, Maui, and we had done some work on the Big Island in 2013 and 2014. And part of that was to try and find likely sites where we might find evidence for this really large event or a number of older events throughout. And we use things, a vibracore, which is essentially a long aluminum pipe with a cement vibrator on top of it, and we just shake it into the ground. This is a 20-foot long pipe. We're able to get most of that in and retrieve a core. Others were just hand-powered gouge augers that we push in, extract them out, and we can see sediment within those. So a number of techniques, but it's basically a crew moving fairly quickly. So we have 3 islands, dozens of sites. There's USGS, UH folks, gouge over a number of trenching things and sort of handheld devices to move, get a sense of where we'd want to return to. And one of those sites was Anahola. And for a number of reasons we can now explain afterwards, but one of the things we found, this is a core, and I actually have some examples of cores that we can touch and feel later. But this is the core, this is the surface, this is just out in the wetland area, and there's a really clean sand, and this particular one is about 20 centimeters. And if you look at sort of the rate of sedimentation, it's around a 1946 kind of age. Much deeper, there was a much thicker sand. It was deeper, therefore it's older. Thicker, therefore maybe from a larger event. It was nearly identical sand, and these look very much like beach sands. And so we're actually working in areas which have nice beaches and then a wetland behind them. So a tsunami or a storm comes through, takes the sand and spreads it out over these wetlands. And then we can core through and you see this clean sand and it's surrounded by peat and mud. So something brought that sand in. And that's what we're looking for. In this particular case, we haven't dated this, but just the depth we're reasonably confident we have a 1946 event. We knew it went into the wetland there, but we do have some dates from this lower sand, and it puts it around 1400, which isn't too far off. It's within 100 or 2 years of the Makawahi cave deposit ages. So that encouraged us that we may have some evidence for this much larger event. So this is what we've done in the last week or so. Actually a sprinkling of the number of cores within Anahola. This is the beach, there's the camp area over here, river mouth. And pretty much through here, it's all DHHL land, and they were kind enough to grant us access. And we were able to do a number of different kinds of cores. We have about 40 meters of vibracore we're trying to send back, a number of other types of cores for age dating, sedimentology, geochemistry, all things that should help us, identify not only that layer at 100 centimeters, we were getting down 4 or 5 meters into the sediment. So we should have a really good picture of the how often events have occurred in that area. And we're also, and these are all distant source paleo tsunamis. It's not, they're 5 hours away. You don't feel an earthquake. It's coming in. And sometimes they're actually really thin deposits, and it takes a little bit more scientific studies to identify them. One of the tools we're using, this is Oregon State University has a veterinarian CT scan for horses. And so we're scanning our cores with this scan. And these are some kukui nuts that showed up in the core, and they often wash up. You see them on the beaches. Well, those were from kukui nuts buried in the sand way back in a marsh, sort of thing. So I'll go quickly about this. We have 2 locally generated tsunamis that I'm aware of. The most recent one was in 1975. It affected essentially Hawaii volcano shoreline. It had local subsidence of 3 meters. The whole ground went down 3 to 3.5 meters. And it generated a landslide, submarine landslide with a wave almost 15 meters high. So that's 45 feet. There were a number of campers killed, in the Halape area. And we've done some work looking at those to compare storm and tsunami deposits. There was an older one, 100 years, they call the Great Kauai earthquake. It was even larger and with run-ups of 20 meters, over 60 feet, and a number of deaths from the landslide and tsunamis. Some USGS folks flew over right after the November 25th event. You can see the evidence for subsidence. The coconut trees are in the ocean, they're still green. Okay, so the whole ground subsided. There's this feature, a tumulus, that in 2007 we flew over. You could still see that feature, but now it's surrounded by land and storm deposit. But there is some uplift. The other thing you can see here, this marked line, that clearly defines where salt water got in and killed the vegetation. So we could actually map out where that tsunami went and get elevations from that. The other thing we saw were these boulders. We could see where they originated, and they've been spread inland quite a ways, over 300 meters in some cases. So these are big blocks of rock. That one of the things we're now looking for to see if ancient tsunamis came through. The people camping out there, there was the earthquake and landslides, the material coming down, so they ran to the ocean. And then they could hear the tsunami coming and ran back the other way. And it wasn't a good place to be in. The other kind of extremely rare, I'll just briefly, are landslide-generated catastrophic tsunamis in Hawaii. And there's been some studies where on island of Lanai, some scientists have found some coral sediment 375 meters above sea level, right? So that's quite a ways up. There's some question about that, but with an age of around 105,000 years ago. On Molokai, they found also some high-level deposits. And the idea behind that is offshore mapping around the Hawaiian Islands have found large debris fields where pieces of the island have slid off into the ocean. And it's these giant landslides that create a tsunami that would probably affect all the islands quite dramatically. They're extremely rare. There's no historical delay. These are all 100,000 years ago kinds of events. And it's sort of like an asteroid or a bolide. It's not, you can't plan for something like that. But it is an area where some of that evidence occurred. This is from a recent paper where it's a mega tsunami deposit where the concrete flank collapse. That's where actually parts of the volcano actually collapses. They're building up and they get oversteepened and a part slides off. Kauai is probably okay because it's old enough and all the stuff's already slumped off. But the Big Island is where they have the most recent one. And let me just, one thing about the Big Island is they have these submerged reefs, coral reefs that you can date. As the Big Island grows up, actually the whole thing is slowly subsiding. You're pushing magma up, but the island itself is subsiding, and you know that rate based on these reefs. So they found scientists near shoreline and up to 61 meters above sea level. But when they dated them, that part of the island was over 400 meters high and 6 kilometers inland, meaning that a tsunami created from this flank failure had a wave that went more than 400 meters in elevation and 6 kilometers inland. So it's not something you can, actually, I wouldn't worry about it, and you can't plan for it. So how we're using these deposits are to extend the short written record. All right, so we can now have a better idea how often and how big. Understand the magnitude of the tsunami if we can. Their frequency, and that's why we're doing the age dates on these. So generally thicker deposits, and then maybe related to size of the tsunami. It's also related to source and other things. But we can certainly get the frequency. We use it to verify models. There's a lot of modeling being done to try and improve it. And then a probabilistic tsunami hazardous, what's the likelihood of something occurring? Is it a 30% chance over the next 20 years, those sorts of things. So next, how can we be prepared or better prepared for some of these tsunamis? And Japan is probably the best prepared country in the world in terms of both understanding tsunami processes and deposits. And I was there for International Field Symposium, and this is actually Daisuke Sugawara in here with the gouge auger, and we were out in a rice field. And he was showing us, he had some examples of some older, deeper deposits. And I believe this is the shrine near that marks the limit of the Jogan. So there was a written history, and Daisuke was one of several scientists who was finding evidence of this large tsunami, much larger than what people thought could happen. And he was in the process of working up, scientists, it takes us a while. It takes, a decade or to put some of these stories together. In terms of preparedness, they have excellent signage maps telling people where you are, where you need to evacuate to. They have seawalls to protect the inhabitants. They do evacuation drills, all the right things you're supposed to do. And then in 2011, they had not a 300-year event, but a 1,000-year event that just completely overwhelmed a lot of their planning and a lot of their engineering stuff. This is our field trip in 2010 out near a beach, and this is it a year later. Structures can survive if they're built properly. These trees were meant to be a bit of a defense, but you can see they were wiped out. Some buildings just never made it. And the casualty in Japan, the rate in Japan would be much higher if they weren't as well prepared as they were in terms of the evacuation drill, stuff like this. Here's another before and after a bridge. You can see how much of the town was devastated. Not only is it the tsunami, but there's fires that are generated as fuel tanks and other things get turned over. This is a set of designed to actually block water flow into an embayment, and they were completely overwhelmed by this event. So even the best planning, you can't always save structures themselves, but if you can get the people out of the way, that's probably the most important thing that you can hope for in those situations. So in Hawaii, you have the Pacific Tsunami Warning Center. You can go online, you can subscribe. I get text messages or emails from them all the time when there's an event. And the kinds of things you'll see a message like this. All right, so there was earthquake parameters. This is Wednesday, 2 days ago. All right, the 7.0, that's not a small earthquake. In the small Solomon Islands, But then based on their analysis, you know, there's no tsunami threat from this earthquake in Hawaii on that. So everyone, you know, I think civil defense in Hawaii is really good. I think they respond well to storms, tsunamis, though they're well prepared. But I think it's up to the people to also be aware of their surroundings and what they're doing. So there are tsunami inundation zone maps. I know all of you have seen that entering tsunami has its own, you know, evacuation zones, those sorts of things. But you can put in your address. You know, here's Anahola Bay, and you can see areas. This is sort of the general inundation zone map, and it fills in that low-lying valley within Anahola. And those are the, you know, everyone should have, you know, you should be prepared as a family and actually as neighbors. I mean, what are you going to do if, you know, it may happen in the middle of the day and you'll have 5 hours warning and there's no problem, but it might be in the middle of a night during a storm and there's a tsunami warning, or your children are somewhere and you're somewhere. Where are you going to meet and what you're going to do? That's always something you should work on. So the final state, you know, don't worry, you know, it's out, but be prepared, and be prepared to take, you know, civil service is there, but if it's a locally generated tsunami, the warning is the earthquake. Long before civil service or sirens or any of that. In fact, no matter where you are in the world, if you're near the coast and you feel an earthquake, you get, you know, don't be a tourist, don't sightsee. If you live in Anahola, if you live on the cliffs around the valley and you know there's a tsunami coming, get your video cameras, set them up, get them right. The scientists would love, you know, we actually need that, look at the sediment and the flow velocities and just make sure, you know, everyone you know is safe, call, get them out of the valley, set up the cameras and just, you know, take nice pictures of that. But, you know, you have to be prepared yourself for all of that. And it's, you know, especially the children. You know, I'm always talking about, you know, what are you going to do? What are you going to do if this happens here, sort of thing, so they know what to do and where to go. Anyway, thank you very much for having us here, and